Hello YouTubers and fellow hams. Well, on the bench today I have this ICOM IC-725 HF transceiver. All mode, all HF bands, general coverage receiver. Graciously donated to the channel by Kevin. Another Kevin, not me. You know who you are, Kevin, and thank you very much for contributing this radio. So, this radio has a little problem. I'm on 7.336 megahertz and it's really quiet. But if I go just a few kilohertz, eh, 7.356, it works. 7.357, it doesn't. And it's like that all the way up the spectrum. In random areas, well, they're probably not random, I'm sure there's a reason, but they certainly appear random. There are ranges of frequency where it does not receive. In the areas that it does receive, it works fine. For example, well, I was listening to Radio Havana earlier, so it works fine, except for certain little ranges of frequency here and there throughout the dial. Now, before I've said it always helps to know the history on our radio. And in talking to the owner, sometime in the past, he attempted to do the Mars modification, where you cut a diode and it opens up the radio to transmit on all frequencies. And he tells me that the diode is D5 and it's on a specific board, and it turns out that there's also a D5 on another board and he got the wrong diode. And he said he soldered it back, but ever since doing that it has done this where it'll drop right out of receive on certain little pockets of frequency all across the spectrum. So I've downloaded the service manual for it. We're going to open it up and we're going to take a look at the PLL board and the IF board, or RF-IF board, and we're going to find the diode that he mistakenly cut, and we're going to check that out. I'm sure he soldered it back in fine, but there might be a solder bridge or a connector problem or something there. So we'll start there, and yeah, let's get into it. Well, we got her all apart and splayed out here on the bench. And this radio is put together like a layer cake. This is the power amplifier module, which also has the low-pass filter network. And it was laying over on this part. It's mostly heat sink. Back here, there's a fan up here in the front to move air through there. This middle board, which is in the center of the radio, is the PLL board. And then on the top side, or actually bottom side of the radio here, is the main RF unit. This is all the RF circuitry, receiver front end, IF stages, modulators for your transmission and generation of the transmitted signal, which then gets passed through a couple of coaxes down to the PA board. And then, as I said, in the middle here is the PLL board. These are the 4 VCOs that handle different frequency ranges of the band. And one of these cans, probably this one, it might be this one, I don't know, I'll have to look closer in the manual, but one of these cans has the primary VCO, which is active with all the bands. Over here is the microprocessor, got a little coin battery on it. And here are the switching diodes that control various functions in the radio. Some diodes are installed, some are opened. What these are all pins on the microprocessor, data pins. And a diode basically changes the state of that pin from high to low or low to high. And by cutting the diode, you alter the state of that pin. You switch a function, right? So like the one function that we're interested in, which is D5 over here, and I'll show a close-up, is the transmission limiting to ham bands only. When that diode's in line, the processor senses that, and it knows to only allow transmitting when you're in a ham band. And cutting that diode allows the radio to transmit all across the HF spectrum, which is commonly known as the Mars mod. It's how you'd open the radio up to use with the military amateur radio service, which needs to be able to transmit on frequencies that are not in the normal ham bands. There's other diodes here that switch various functions. Baud rate selection for the, I guess the serial input. This must have a cat control on one of these accessory connectors here, which is kind of cool. But various other functions are switched there. So that's the diode that he cut to enable Mars. And I think one of the first things I'm going to do in testing is I'm going to reverse that mod, resolder that pin, which will again limit it to transmitting in the amateur bands. I don't think that that's the problem. Just by the way it's behaving, my thinking is that the primary VCO is out of adjustment. In a PLL, phase lock loop circuit, which keeps the frequency very stable versus a regular VFO, you've got these voltage controlled oscillators, and they shift in frequency as you're tuning up and down the dial, and then they work together to lock the frequency in place by detecting a phase shift in the oscillator and adjusting for it. And they use variable voltage oscillators, voltage controlled oscillators. A little varactor diode and changes capacitance as the voltage changes across it, and that's how you control the oscillator. So their adjustments are very important. They operate over a specific voltage range and versus where you're at on frequency, and they have to track properly. If they get a little out of whack and their voltage gets a little too high or a little too low at the edges of the frequency range, they will go out of lock, meaning they're no longer synchronizing and holding the frequency in place, and the receiver goes dead. It doesn't have a frequency injected into the mixer, and it just stops receiving. So I'm thinking that actually the problem is just coincidental. It just, one of the VCOs is a little out of adjustment, and it just manifested itself about the same time he performed this modification. But to be absolutely thorough, I'm going to reverse that modification. And then on the other side, on the RF board, is where he erroneously cut D5, and it's over in here somewhere on this board. And he soldered it back in, and it looks like he did okay, but I'm going to go ahead and remove the solder and resolder that diode just to make sure that it's okay. I can trust that it's okay because it looks like he did it fine, but the only way I'm going to know is if I do it myself, and so we're going to do that. So I'm going to get the soldering iron heated up, and we'll reverse this mod. And while the soldering iron's heating up, I'm going to be digging through the service manual and figuring out how you do the VCO adjustments. It's going to be a little difficult to do. Since the PLL board is in the middle of the radio, you actually have to have the PA moved out of the way in order to get to these adjustments. And it has one cable here that has to plug in here, which won't reach. Maybe it'll reach if I put this up at an angle. Yeah, just. So I guess that's how I'll have to operate the radio when I'm doing the adjustments. These two coaxes here are RF to and from this section. So one of these is RF coming into the receiver when you're in receive mode, and then there's a transmit-receive relay in here. And the other one is the RF signal generated by the radio going to the driver and power amplifier. I can leave those unhooked. That's not going to hurt anything, but I think I want to have this control cable hooked up because this also provides power to the rest of the radio. This cable here is power coming out of here to the rest of the radio, And I don't know if it provides power on this or not. I think this might just be switching for the filters, where the radio can switch in and out the low-pass filters for various frequency ranges on the band, depending upon where you're operating. So I might be okay leaving that unhooked. But, yeah, I don't know. And then we've got the speaker connector, which goes to the other side of the radio. So that's, yeah, it's not an easy radio to make these adjustments on because of this way that it's built, because of this board being in the middle of the radio. It's hard to get to. So I've talked enough. Let me get the soldering iron heated up and reverse these mods, and then we'll test it again and see if that took care of the problem. Okay, I've reversed the mod and got the radio reconnected, all the modules reconnected, and I was testing it out, and we still have the problem. Certain frequency ranges it just cuts out. So I guess the next thing I'm going to have to do is figure out how to get set up to do the PLL adjustments. And we'll go through that alignment procedure and see if that takes care of it. So we're doing the PLL adjustments. And got the scope hooked up to the recommended test point. One thing I did, which I hope you can see this on the camera, since I need to refer to the manual on the computer for the steps, they want you to adjust these trimmers, and they've labeled them on the diagram or on the steps, but they don't. The picture's on a different page. So I wrote the trimmer numbers next to the holes here. So as I move through the page, I don't have to keep on referring back to the diagram to make sure I'm adjusting the right one. So the steps are pretty straightforward. They give you a setting for the front panel. 7.999999 megahertz, mode USB, and receive mode. They tell you where to attach the scope to do your voltage measurement. And they tell you what cap to adjust and what voltage to target. And they want you to hit 6.5 volts on 3 of these. So I've just done the first one. It was way out. It was at 7.4 volts where it should be 6.5. So we've adjusted that. Now we're going on to number 2, step number 2, which will be adjusting C46. Displayed frequency 14.99999 megahertz. So I'll reach around here. 9, 10, 11, 12, 13, 14.99999 megahertz. USB, that's what we're at. Should be 6.5 volts. And it is 6.72, so that's only a little bit off. So let's make that adjustment. Get the right tool. And that's 46, and we're going for 6.5 volts. So alright, there we go. Step 3, 21.9999999 megahertz. So 7.5. All right. That's the PLL adjustment. Now we'll turn it off, hook things back up, and we'll see if the receive problem is fixed. Well, I think I might have found the problem. Part of the adjustments is the DDS loop, which is the main part of the frequency locking. The tricky thing is to make this adjustment. You see this little coil right here? Those wires all spread out? I've been spreading them. At the test point, you're supposed to see, when you're on AM at 14.12650, which is where I'm at, you were supposed to see 1 volt. And it was like 4 point something volts, way out. So I've been slowly spreading these turns on this coil just a little bit at a time. I'm at 1.2 volts, so I'm getting close. So I'm just spreading these out just a little bit at a time. Still 1.2. 1.12. almost there. I've had to spread them quite a bit. Now they're coated in wax to keep them from moving. 1.12. $960 millivolts. Went a little too far. There, 1 volt. Okay, now 14.12649. Right about there, we should see approximately 2 volts, and I'm seeing 2.16. So we are now correct. Let's put the shield back on this guy and see if it changed. No? Good. And yeah, about 1 volt when we're on that frequency. So now we are correct. Okay, good. Now I got to sandwich it back together again and test. After doing the VCOs here, it still was messing up. So now we've got that DDS loop adjusted, which was really tricky. Let's put it all, hook it all back up and see if it receives. Well, you can't see it on camera, but I'm smiling right now. Here we are receiving. And I'm moving right on through the ranges where it was cutting out before. And it's doing just fine. Let's see. One band it wouldn't hardly receive on at all was 17 meters. So there's 17 meters. And I'm moving right through the band just fine. Yeah, that was it. The DDS loop adjustment was the problem. How about that? Okay. Well, what to do next? Okay, so now I've got the main problem with the radio fixed. Yay. I think I'm going to do some cosmetic work on this front panel. These knobs and this front panel is pretty grungy, so I think I'll pull these knobs all off and wash them up and clean up the front panel, and we'll reassemble the whole radio. So I've popped the front panel off. It's kind of dirty. And I've also taken all the knobs out. The rubber ring off of the VFO knob. The knob itself, the aluminum is a little grungy and dirty, so we'll clean all that too. And I had somebody ask about, what do I use to clean these things? And it's really, really simple. This is a little bit of water with just a couple of drops of dish soap in it. You just need some soap. And this is just plain water. And I got a rag. So if we're doing the front panel, I'm just going to dampen my rag with the soapy water, squeeze the excess out. Because you only want damp, you don't want to get drops of water into everything. And I'll just, give it a quick initial wipe here. We'll just get the bulk of the grunge off of here. Get the rag wet with damp with just water. And we'll go back and we'll wipe off the soapy residue with just the water. And I'll do this 2 or 3 times just to get this good and clean. And then once I'm satisfied with it, I'll take a dry clean rag and dry it off real good and inspect it, and then I might go over and get a few problem spots again. On the front of the radio, which you can't quite see, there we go, you can kind of see it now. The LCD and the meter I'll treat a little more carefully with a small rag and some, maybe just a spritz of Windex on the rag, and just get the dust off of those. I mean, they're fairly clean. They've been underneath the glass on the front panel for the longest time, so they're mostly clean. I'll go around these controls and I'll get the dust and grit out of here on those. I'll clean these embedded knobs on the sides here so they're nice and clean. The VFO encoder was really stiff, so I just put one very small little dot of machine oil on it and exercised it, and now it's nice and smooth. And I took a small screwdriver clip and I cleaned the grunge and dirt out of it. So yeah, it's just taking your time. The knobs, the way I do the knobs is a toothbrush and soapy water. So I'll take the knob over in the soapy water, and then I'll just scrub it real good all the way around. Get all the finger oil and stuff off of it. Rinse it off in the clean water, and that is nice and clean and shiny again. And then we'll just dry it off with a rag. So I'll do that for each of the knobs and the rubber bushing that went around the VFO knob. The case itself, a neat trick on the case and case plastics. If you take a rag and you just take a little WD-40 and just spritz the rag, just get it not even damp, just a tiny bit of WD-40, and wipe down the case with that. That does a tremendous job of cleaning the case. And then a dry rag to take off the oil residue from the WD-40. So once I get this all cleaned up and put back together, I'll give you a good look at the finished product, and I think we're going to have a nice clean looking radio. All right, so previously it was around 7.355 that it was dropping out, and it's steady and stable right now all the way up. In fact, I can go anywhere on the HF spectrum and it's nice and stable. So we have definitely resolved the issue. Let's see if we can get into e-cars.
All right, very good. That's Kilo Bravo 3 Zulu Victor Portable Starting Camp in or around Harrisburg, Pennsylvania. I guess you're somewhere in Dauphin County or maybe a little north if you're doing some serious hunting. But good to hear from you, Jim, and your setup is doing a fine job. Anything else we can do for you this morning? Over.
Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.